Imagine the middle of a busy Friday night shift at a massive 911 dispatch center. Dozens of operators are talking, typing, and tracking units. Then, without warning, every single monitor in the room flashes and goes dead. Modern policing is entirely tethered to a digital nervous system built on a Big Three architecture. You have the CAD, or computer-aided dispatch, acting as the central hub. This links outward to the MDTs, the mobile data terminals inside the police cruisers, and inward to the RMS, the massive records management systems that store the department's data. Because these systems are so highly integrated, a single severed fiber optic cable, a targeted cyber attack, or a ransomware breach can take down the entire network at once. All three systems are instantly wiped out. The immediate crisis is terrifyingly simple. The 911 phone lines operate on separate utility networks, so they keep ringing. Crimes and medical emergencies continue happening. But the dispatchers and the officers in the field are suddenly flying blind, stripped of their digital maps and instant communication. Surviving a sudden digital collapse like this requires abandoning software entirely. Departments have to execute an immediate pivot to a strategy called tactical continuity, relying strictly on human memory, physical paper, and deeply ingrained behavioral protocols. When the CAD system fails, the dispatch floor has to instantly shift from a highly automated digital hub into a manual triage center. The quiet clicking of keyboards is replaced by shouting across the room. Normally, the CAD software is doing the heavy lifting. It automatically logs incoming calls, prioritizes them by severity, and uses GPS to map exactly which officer is closest to the emergency. To replace that software, dispatchers execute a fallback protocol known as dispatch continuity. They turn away from their blank screens and move to giant whiteboards. This grid shows how it works physically. Specific physical status cards represent individual patrol units, organized manually into city sectors. The dispatcher now has to map the entire city in their head, relying purely on spatial memory to track where every officer is. When an urgent call comes in, the dispatcher calculates the nearest unit and physically moves their status card across the board to intercept it. The logistics of taking a 911 call change too. Call takers write down the emergency details on physical intake slips. Then a designated runner, a scribe moving physically across the floor, ferries those handwritten notes directly to the radio dispatcher. Without the digital map, the dispatcher's working memory, combined with physical paper tracking, becomes the sole navigational engine for the entire city's police force. Out on the streets, the patrol officer faces a different kind of isolation. The mobile data terminal mounted on their dashboard is now just a useless brick. Officers lose their ability to communicate silently. They can no longer run a license plate with a few keystrokes, read the detailed history of a 911 caller, or send direct text messages back to dispatch. Everything must be spoken aloud. This creates a massive potential for congestion over the airwaves. To prevent the system from crashing, departments immediately initiate radio discipline, forcing all communication from hundreds of officers onto a single, shared voice channel. Look at how this bottleneck happens. Under radio discipline, all those wide, scattered digital data streams suddenly narrow into a tightly controlled priority queue. Strict brevity rules go into effect. Only critical, life safety traffic is allowed on the air. If an officer wants to report a routine traffic stop, they have to wait. But the crisis extends beyond immediate response. The loss of the records management system threatens the legal documentation needed for court proceedings. An arrest made during a blackout still requires an airtight chain of custody. To solve this, officers pull physical outage packets out of their cruiser trunks. These packets contain thick stacks of paper forms, warrants, booking sheets, and evidence logs, ensuring all legal data is captured manually until the servers come back online. Without the extreme brevity of radio discipline and the meticulous filling of offline paper logs, the loss of a digital connection would quickly devolve into operational chaos and failed criminal cases. We can see exactly how well these manual protocols work by looking at a recent case where a major city was hit by a targeted ransomware attack, causing a total sudden blackout of their CAD and RMS networks. Within minutes, department leadership identified the severity of the outage. They didn't wait for IT to fix the problem. They authorized an immediate citywide shift to their analog fallback procedures. This line graph shows the operational outcome. Comparing emergency response times before, during, and after the total blackout, we see only a minimal spike right at the transition period. The analog systems absorbed the shock, and public safety was maintained. A seamless transition like that doesn't happen by accident. It relies on meticulous outage planning and continuous, decidedly unglamorous training drills, rehearsing the worst-case scenario until it becomes muscle memory. The success of tactical continuity comes down to these three specific pairings. When the CAD fails, the room shifts to dispatch continuity. When the MDT dies, officers pivot to radio discipline. And when the RMS locks up, the department falls back on physical paper forms. Law enforcement software, no matter how advanced, will eventually fail. But a highly trained human workforce executing strict analog protocols ensures that the 911 system never truly goes offline.